Now we are learning solid state, sixth chapter. In that already I have studied about crystal lattice, nothing but the arrangement of molecules, atoms or ions throughout the crystal is called a crystal lattice. Now definition of unit cell is a basic repeating structural unit of a crystalline solid is called as unit cell. And coordination number is nothing but the number of nearest neighbors that surrounding a particle in a crystal is called as coordination number of that particle. And this unit cell is classified into primitive and non-primitive unit cell. And primitive unit cell is nothing but it contains only one lattice point. And that is the lattice points are present at the corners of a unit cell. And in non-primitive unit cells, there are additional lattice points either on the face of the unit cell or body center or basic of the unit cell. Now there are 7 types of primitive unit cells and it is nothing but cubic, tetragonal, orthorhombic, hexagonal, monoclinic, triclinic and rhombohedral. Here in diagram already we learned that depending upon the intercepts, the length of the intercepts it is and angle between the axis it is classified as cubic, rhombohedral, hexagonal, tetragonal, orthorhombic, monoclinic and triclinic. These are 7 primitive unit cell. And in this it also in cubic unit cell we have body centered and face centered unit cell. In this body centered and face centered unit cells are non-primitive unit cell since it contains an atom at the body center and here at the faces. And in tetragonal unit cell, in addition to one primitive unit cell, additional non-primitive unit cell that is body centered unit cell is present. And in orthorhombic unit cell, in addition to primitive unit cell, it contains body centered unit cell, face centered unit cell and basis face centered unit cell. And addition to monoclinic unit cell, addition to primitive unit cell, it contains basis face centered unit cell. Now we are going to learn about the types of unit cell, that is here simple cubic unit cell. Simple cubic unit cell, it contains, you have to draw like this and a unit cell is drawn and these are the corners and at the corners there are 8 corners and 8 corners, this is called as corners and totally 8 corners are there. Here it contains, in simple cubic unit cell, it contains identical atoms or identical ions or identical molecules. Here the atom or constituent at the corner is divided by 8 other unit cells. You just imagine that around this unit cell 3-dimensionally the other unit cells are surrounding. So in addition to this unit cell 3-dimensionally other unit cells are present and the atom at the corner is shared by 8 other unit cells. So now if we find the number of atoms in simple cubic unit cell, simple cubic unit cell is nothing but Nc by 8. Nc is nothing but total number of atoms at corners. So we know already that there are 8 corners, 8 atoms are present and each atom is shared by 8 other unit cells. So divided by 8 equal to 1. So in a simple cubic unit cell only one atom is present. Okay. The 8 corners, 8 atoms are present. This is how the atoms are present in simple cubic unit cell and the cubical arrangement is shown here. These are the corners. It is face, these are the face and center of the body. And here if you look at this diagram, here the atom at the corners are touched. Here the atom present at this corner is touched by this atom, and the same way all the atoms are touching, but the atoms are not touching diagonally. Here this way diagonally the atoms won't touch, but one atom at corner will be touched by another atom at the corner. Such a way it is arranged here, but the atoms will not touch diagonally. Here a space is shown here. And if you look at this diagram, if this arrangement is in 3 dimension, here this such arrangement will be there at the back side, above, side and below everything, and one atom will be surrounded by 6 other atoms. So the coordination number of simple cubic unit cell is 6. So here coordination number of each atom is 6 and number of atoms in simple cubic unit cell is 1. Now let us pass on to body centered cubic unit cell. Here you look at this diagram. Here the atom are present at corner and at the center. This is the body center. Here the atom is present, one atom is present. So this belongs to non-primitive unit cell. And here in same way the atom at the corners will be touched by the atom present at another corner, but it won't touch but here the body center in simple cubic unit cell only, atom at the corner will be touched by another atom present at the another corner. Here look at this diagram. In this diagram, green color spheres shown the atoms present at the corner, and pink sphere shows the atom which is present at the center, body center. And here in cubical arrangement it is shown like here. And if you look at this diagram, here the atom at the corner is not touched, another atom at the corner, but the 8 corners, the atom at 8 corners are touched by the atom which is present at the center of the body. Okay. So here since 2 types of atom, one is at the corner and another one is body center, and we know already that the atom present at this corner is shared by 8 other atoms in 8 other unit cells. Here the body center is not shared by any other atom. So total number of atoms present in BCC unit cell, BC is nothing but body centered unit cell. Here NC by 8 plus NB by 1, that is total number of atoms at the corners 8, and total number of atoms present at the body center is only 1. And we know very well that the atom at the corner is shared by 8 of the unit cells, so 8 by 8 plus 1 by 1. It won't be shared by any other unit cell. So total number of atoms present at the body center is 2. And if you look at the diagram here, if this arrangement is shown 3-dimensionally, here the atom which is present, one atom is surrounded by 8 other atoms. So the coordination number is 8. So each atom is surrounded by 8 nearest neighbors and the coordination number is 8, and total number of atom present in body centered cubic unit cell is 2. Body centered unit cell, here an atom is present at the center of the body, and here it is touched by atoms present at the corners in such a way. Here okay. Here and here. Now next let me pass on to face centered cubic unit cell. In face centered cubic unit cell, we know very well that the atoms are arranged like this, and here at the face center totally 6 faces are there in a cube, and 8 corners, 6 faces, and each face It contains one atom at the center of the face and conversely 8 atoms. And here if we calculate the number of atoms present in FCC unit cell is nothing but Nc by 8 plus Nf by 2. We know that the total number of atoms present is 8 and each atom at the corner is shared by 8 other unit cells, so 8 by 8 plus Nf by 2. Nf is nothing but number of atoms present at the face center. Totally there are 6 faces, so 6, and each atom at the face is shared by 2 other unit cells, so divided by 2. So 8 by 8 plus 6 by 2 equal to 1 plus 3 equal to 4. So total number of atoms present in face centered cubic unit cell is 4. Now if you look at the how it is shared, here it is the atoms won't touch at the corners. The atom present at one corner will not be touched by atom present at the another corner, but the atom present at the face center is touched by the atom present at the 4 corners. Here look at this diagram. We already learned that these are the faces 1 2 3 4, one above, one below, like this, and the total number of atom present at the corner is 8. Now here in this diagram I shall explain how to draw only one face. Here this atom present in the face will be touched by 4 corners, and this will be touched by 4 corners, and this will be touched by 4 corners on that face. And here like this it is touched, and the atom present at one here in this corner, it will be touched by one above and one below, one above and one below, and here below, above and below, and here it is above. Like this it is drawn. So if you can see only one thing, this is one face at the center, corners 4 corners are there, and it will be shared by atom present at the 4 corners. Like this the diagram is drawn here. So it is not easy to draw this diagram on a 3-dimensionally, since it is a 3-dimensional arrangement. It will be tough to draw, but with the help of small circles the particles content are shown here. So the atom present at the corners is shared by the face center atom at the face center, the atom present at the face center. So total number of atom present in face center unit cell is 4.